In this video, we are going to learn how to graph absolute value functions, um, inequalities specifically, okay? But before we get to that, I want to make sure that we understand and remember from last week how to graph those absolute value functions. So if you had trouble with that last week, this is kind of going to be a recap, okay? So first, if we graph, and I don't have this on your notes, so just hang with me for just a minute here. But if I wanted to graph the absolute value of x, okay, if I wanted to graph that, if I came down here and let's say that I chose the point 0, -1, 1, 2, and -2, okay? If I put in 0, of course, I'm going to get 0. If I put in -1, the absolute value of -1 is 1. So remember, we're doing f of x equals the absolute value of x. I'm going to write that down there so you can see it. So if I put in 1, the absolute value of 1 is 1. If I put in 2, the absolute value of 2 is 2. And if I put in -2, the absolute value of -2 is also 2. So if I came over here and I graphed these points, I'll do it with a marker. If I graph these points, this graph would look like this. So 0, 0, -1, 1, 1, 1, 2, 2, -2, 2. If you'll remember, it was a graph that made a V. So we had something that looked like that, okay? Now what we're going to do, just to remind you, okay, what happens if they add something outside or inside that absolute value function? So let's just remind ourselves of what that looks like, okay? So if they add 1 out here, that means that they move the graph up 1 unit. So instead of starting at 0, 0, I'm going to start at this point, 0, 1. And that makes sense because if I came out here and I did an XY and I put in 0, the absolute value of 0 is 0, and 0 plus 1 would be 1. And then it's always up 1 over 1. So this graph would look something like this. Okay? Now, if they do a -2 in here, okay, if they do this -2, now, if it's on the inside, if you'll remember, it was x minus h, okay, in there when we looked at the vertex form. If this was a minus, then that meant it moved it to the right 2 units. So instead of my vertex at 0, 0, it's going to move to the right 2. It's going to be there, okay? And when I move it there, that means that now all of my points are shifting over to here. So this graph is going to look like that, okay? All right. Then if they put the 3 out in front, okay? Now we might have to do a little bit more work here to see what this one's going to look like. I don't know if you remember or not, but putting a 3 in the front meant that we were stretching it. And I used an illustration of a rubber band, like we take the rubber band and we pull it and we stretch that rubber band out, okay? So if I put, let's just say 0 in, okay? At 0, I'm going to get 3 times 0 is 0. So I'm still going to be at the same vertex. But what if I put in 1? Well, the absolute value of 1 is 1, and 3 times 1 is 3. So at 1, I'm going to get 3, which means at -1, I'm also going to get 3. So you can see that this graph is going to be, it's stretched it out, okay? So it's going to look like that. Then if we had a negative in the front, like this, we had that negative out there, okay? So the negative, I'm still going to have my vertex at 0, 0, but hopefully you remember that that flipped it. It made it down here. So like if I put in 1, absolute value of 1 is 1, but then that would give me -1. So at 1, I'm going to have -1. And at -1, I'm also going to have -1. And this graph is going to continue down like this. Okay, hopefully that's a good refresher of what we did last week. And the reason I wanted to do that is because I wanted to remind you what these look like before we look at inequalities. So now let's look at inequalities, okay? So now let's look at inequalities here. All right. Graph f of x is less than the absolute value of x minus 3. Now there's a couple things I want to tell you before we get started. If you have a less than or greater than sign, when you graph it, you're going to graph with a dotted line. Dotted line, okay? So I'll write here, dotted line. If you have less than or equal to, or greater than or equal to, so if they add that equal to in there, then you're going to graph with a solid line. Okay? Solid line. So let's go over here. Absolute value of x minus 3. Now remember that minus 3 on the outside means that it moves it down 3 units. Okay? Moves it down 3 units. So if I take the point 0, 0 of the vertex and I move it down 3 units, that's here. Now it still has that same slope, up 1 over 1. And if you don't believe me, you can put in points and check them if you want to. So now those are my dots to go by, but this is less than, so that means I'm going to use a dotted line. Okay, it's going to be a dotted line. Then the rest of this is that you have to shade where it's less than. So everything less than. Now, one of the things I like to do, hopefully you can tell that that means you're going to be shading down here on the bottom. But if you can't, and you don't know where to shade, you just have no idea where to shade at, choose a point. Choose the point that's 0, 0 up here. Is this statement true if I put 0, 0 in? So is 0 less than the absolute value of 0 minus 3? Does that hold? Let's see if it does. 0 is less than the absolute value of 0 is 0. 0 is less than 0 minus 3 is negative 3. Is 0 less than negative 3? Hopefully you said no, it is not. Negative 3 is definitely less than 0. So that means any of the points up here, they don't work. Anything up here doesn't work. So that means I need to shade everywhere down here. Okay? So the difference in graphing these is that you're going to be doing dotted and solid lines depending on whether you have an equal to there. And you're also going to have to do some shading. So let me try another one with you. F of x is less than or equal to x plus 4. Okay, if I do f of x is less than or equal to x plus 4. This plus 4, remember it's x minus h in there. If it was minus, it moved it right. So since this is positive, that means it's going to move it to the left. So I'm going to go left 4. 1, 2, 3, 4. This is going to be my new point there. Okay? Now, if we try this, and if you want to, you can. So that's the point negative 4, 0. Okay? That's where my starting point is. Okay, what if I put in negative 3? Okay, if I put in negative 3 plus 4 is 1, and the absolute value of 1 is 1. So I get that. What if I put in negative 2? Negative 2 plus 4 is 2, and the absolute value of 2 is 2. So at negative 2, I get 2. Hopefully you can see that this is following that pattern. So it's going to do the same thing over here. Now, this time it's an equal to. So this time I don't do a dotted line, I do a solid line. This time I do a solid line. Okay, now, less than or equal to, that means I'm going to shade everywhere below. So all this is going to be shaded down here. Okay, let's do another one. F of x is greater than 1/2 x. Now you may want to do some points here just to know what that 1/2 is doing, okay? So I'm going to pick wisely my points. Now my vertex is still going to be at 0, 0, but I'm going to choose, say, 2 and negative 2. Okay, if I put in 2, the absolute value of 2 is 2, and half, let me write this out here for you, half of 2 is 1. So that's going to be 1. So at 2, I get 1. Now remember before it was 1, 1. Okay, so this It's pressing it out. This is a compression. If I put in -2, that's still going to be half of 2 because the absolute value of -2 is 2. So it's still going to give me 1. So at -2, I also get 1. Okay, I'm going to go up and choose 4 and -4. Okay, if I do the absolute value of 4, that's 4. And then half of 4 is 2. So at 4, I'm going to get 2. And at -4, I'm also going to get 2 because it'll give me the same thing. Okay, now, this does not have an equal to with it, so that means that I'm going to have a dotted line. Now, you can tell this is going up 1 and to the right 2, up 1, right 2, up 1, right 2. Okay? Up 1, left 2, up 1, left 2, up 1, left 2. Okay, so this is a dotted line. So we look like that. Now, this is greater than, so I'm not going to shade below it, but I'm going to shade above it this time. Everything above it is what works. Okay, one more. F of x is greater than or equal to -2x. Okay, now my vertex is still going to be at 0, 0. And by the way, guys, if you have trouble deciding what these are going to look like and you just can't graph these, use Desmos. Graph these on Desmos and then put them on your graph. I am fine with you doing that, okay? So if you need to use Desmos, please feel free to do so. Okay, I'm going to choose some points here, x and y. So I've got 0, 0. What if I put in 1 and -1? Okay, if I put 1 in, the absolute value of 1 is 1, times a -2 is -2. So at 1, I'm going to get -2. And at -1, I'm going to get the same thing, -2. What if I put in 2 and -2? Okay, if I put in 2, the absolute value of 2 is 2, and then 2 times -2, is -4. So at 2, we get -4. 2, 1, 2, 3, 4. And at -2, we also get -4. So hopefully you can see what this is doing, okay? Now, this is an equal to, so therefore I'm going to have a filled in line this time. Okay? Now it's greater than, so I'm going to shade everywhere above that line. So that means I'm shading everything up here. Okay, guys, if you have any questions, as always, let me know.